was a good way to start live with a dirty lens, hey? Okay, hello. I am forgetting everything today, so I'm just going to go and put a quick post on Facebook to tell people we're here. And whilst you are waiting, we've got something to think about. You can grab some Lego bricks or some pegs if you want to use this. A calculator would be highly recommended. Something to write on would be highly recommended this lesson too. If all else fails, you can also do things like and subscribe. You could go over to the Facebook post and say hi. I'm just putting a post on there now. Okay. Hopefully that's working. Hopefully that is working. Okay, yeah, there's a post there. But just whilst I get myself sorted, do have a go at this. Have a little think about it. See how you feel about it. Okay, I think I'm about ready. Good morning, Matsuv! How are you doing today? It's Friday. I love a Friday. I am Ruth. This is Joyful Maths with Ruth. This is my GCSE maths lesson, which is also suitable for Functional Skills 1 and Functional Skills 2. What we will do today is we are going to focus really deeply on the understanding of this topic, which is simple. I'm using inverted commas because I don't like it, but it's how the exam board describe it. So I had to use the words so that you can find resources to go with it if you need to. Simple, ratio and proportion. We'll focus on the understanding. And then afterwards, hopefully, you have planned to do some practice, and I have linked you to a load of that in the workbook. You don't have to have the workbook for this lesson, but if you want to find all of that, you can just head to my website afterwards and you can download it, and there's links you can just click on to videos, exam practice, other types of practice questions and things like that. Right, let's get started with this. I asked you a question about what are their names again? Carly and Hannah. Who gets paid more per hour? Now, I have the fortune of teaching this lesson on a Tuesday on Facebook too. So I've got some of the answers from there, even though you can't chat to me right now. I've got some of the answers from that so that I can use that today to help us with this. All right. Okay, so let's have a little look at this question. She says, oh man, I need to change my slide and I've run out of hands. Let's do it. Here we go. So Carly gets paid £58.75 for 5 hours of work. Hannah gets paid £67.50 for 6 hours of work. But I wanted to know who gets paid more per hour. Some people chose Hannah. They said she gets paid more because she got more money. Some people chose Carly because they actually looked at how much she got paid for 1 hour and decided that was what I was asking for. And then other people just said, I don't know how to work that out. Can you show me how to work that out? And I said, absolutely, I can. Let's have a look at this and see what we end up figuring out about this and how we would go about looking at this. So sorry, I've got a bit of a cough. It's getting a little bit chesty. I'm hoping it clears up soon, but apologies if I do cough during the lesson. We can show this a couple of different ways. We can use it physically to represent it. It can be used as a ratio and proportion, this question. So I'm going to show you both. I've just shoved all my stuff on the floor, so just give me a second whilst I go and pick that up. I don't know why I thought that would be a good place. So I asked you if you wanted to join in with this to bring some pegs or some bricks or something. The idea is that you just need things that are the same length as each other. Okay, and we're going to look at Carly and how I can use this physical representation to help us understand this question. And then I'm going to show you how we can go about drawing this, because drawing it is a very valid way of working something out in an exam. Can't take pegs into your exam, unfortunately, but you can draw things out. And drawing, I was reading last night about how Pythagoras used drawings as proof for platonic solids. So, even like the great, did Pythagoras work out all his own stuff? It's arguable he might have stolen it from some other people, or some other people worked it out first. But, let's just say he's a great god of maths, and he actually did prove things through drawing. So, really good use of maths. Let's have a look at Carly then. So I said Carly earned 50, she says, where's a pen? My gosh, I said I was ready. What was I doing? I said that Carly, I'm going to put a C for Carly because I'm writing upside down and I find it hard. She earned, now, there we go, pound sign, that worked out well, £58 and 75 pence for 5 hours of work. There we go, for 5 hours of work. So what I can do is I can write that as a ratio. So for the ratio, if I'm doing the amount of money to the amount of hours, I would keep it that way round. And I would put I would write the 5 first, £58.75 to 5 hours. And I might put a H there to remind me that that's hours. You can put units into ratio. Then physically, if I want to represent that, I'm going to grab 5 blocks, 5 pegs, 5 whatever you've got, and I'm going to line them up to represent the 5 hours. So 1, 2, 3, 4, 5. So there's my 5 hours. That's the 5 hours that Carly worked. And we know that in that time, we know how much she earned. She earned £58.75. Well, I wanted to know how much she gets per hour. So per hour would be 1 hour. So that's 1 hour. So I'm simplifying this ratio. I'm trying to work out how to get from 5 hours, I'm trying to work out 1 hour. Well, here I've got a picture that shows me exactly that. 1 peg is 1 hour. I've got 5 pegs here. So I'm going to need to share this amount between these 5 pegs evenly. This is why we wanted these things to be roughly the same size, so that we're showing that they're all worth the same amount. So I'm going to need to do this £58.75. Sometimes I say, if I talk too fast, I muddle numbers and letters up. So I've jumped and I missed my 8 there. So apologies. I'll try and talk slower. My brain just gets too excited. So I'm going to do £58.75 divided by 5. So I'm using this fraction as a divide symbol there. And we can do that either using long division, or you could just pop it into your calculator. So I'm just going to pop it into my calculator here. Depends what paper you're doing to what you're going to do here. And if you need some practice on doing division without a calculator, you can head to my number sense lessons on YouTube and just have a look at those. There's some there. divided by 5. Press equals. We get this fraction answer. So I keep it. We go to the S to D button on my calculator. Look at your own calculator, though, for the settings of this. If you've got one of the most up-to-date Class Whiz calculators recommended for the GCSE, you have to do shift and go into the settings to change it. It's a little bit more complicated. But that gives me £11.75. So she gets £11.75 per hour. So we can say that, we can label it on our diagram here, or I can write it as a ratio. I can say it's £58.75 for 5 hours. It's £11.75 for 1 hour. So that is my information for Carly. What about for Hannah? We were asked to compare these two people. So we need the same information for Hannah. So what I'm going to do here is I'm going to show you how I would, instead of using the pegs, how I'd adapt that using a drawing so that you can actually use it in an exam situation. So I chucked these on the floor last time and I regretted it later because I wanted to use them again. So let's have a look at this. I'm going to use something that's called, I'm doing that talking too fast thing again. Calm down, Ruth, calm down. I'm going to do something called a bar model here. I love bar models because they're really, really flexible. But essentially, I'm going to draw out those bricks or those pegs. Hannah was working for 6 hours. Oh, I need to put the money first. Keep it consistent. She got £67.50 and she worked for 6 hours. We want to know how much she's going to get for 1 hour. So I'm going to draw out a set of boxes. I'm going to draw 6 of them. And we're going to try and keep them roughly the same size. You can see I'm not doing that absolutely perfectly. This is for me, though. It's not for anyone else. This is for me to understand my working. So we know that all of those boxes altogether are worth £67.50. If I want to know what goes into just one of them, I'm going to have to share that £67.50 by 6. So I'm going to have to do £67.50 divided by 6 to get what goes into those. Should we do a little long division here? See what that would look like on a non-calculator paper. Well, I'm not going to use official. I'm going to use a shorter version of division. So I put 6 on the outside. 6 into 6 goes once. 6 into 7 goes once with a remainder of 1. Put my decimal in the same place. 6 into 15 goes twice because 6 times 2 is 12 with a remainder of 3. 6 into 30 goes 5 times. So I can put £11.25 in all of these boxes. I'm going to just shift that. So it's my arm holding it up. I can put £11.25 in each of these boxes here. If I want to, if I need it for anything. But I can also just not, because this is the actual information I need, the 1 hour. So I'm just going to shift that out of the way so I can fit it on here and say that Hannah, let's put a H for Hannah, gets £11.25 for 1 hour. So we need to compare the two of them. We need to compare them now. So if I just bring Carly's information back, bring it back over here. Hannah was getting £11.25 per hour, but Carly was getting £11.75. So actually, for each hour, Carly is getting more. She worked less hours, so she got less money. But per hour, she's actually earning more money. Okay, so we need to do a few things today in this simple that I don't believe is simple. I think things are simple when you find them simple, not when somebody tells you they're simple. Does that make sense? But I also get the examples trying to differentiate between this and doing other calculations with ratio. I just think they could have chosen better words. Anyway, I'm going to get over it, promise. So I'm going to do a little match it up activity for you now. If you've got the workbook, this is in the workbook. Otherwise, you can just think these, or you can put them on a piece of paper or something like that. Okay. You've got 3 ratios and 3 pictures, and I want you to match the ratio to the picture. So I'll show you them now. Here we go. Oh, can you see those? So here's the 3 ratios. We've got 1 to 2, 3 to 4, 4 to 3. And these are the 3 pictures I want you to match them up with. We've got Here's a picture of cars, and I want you to do the ratio of blue cars to red cars. Here's a picture of some mugs, and I want the ratio of yellow mugs to green mugs. And here's a picture of some sweets, and I want you to do the ratio of lollies to chocolate, please. So I'm going to give you a little bit of time to have a little think about that. So if you think the mugs are in the ratio 1 to 2, you would draw a line between those two. Okay, so I just explained that one more time so we've got 3 pictures. We've got the cars, the chocolate and the lollies, and the mugs. And it tells you what ratio I would like with each picture. And then we've got 3 ratios, 3 to 4, 1 to 2, and 4 to 3. I want you to match each of the ratios to a picture. So if you think 1 to 2 goes with mugs, you would draw a line between those two. Okay. I hate to rush. I don't like to rush people. I think because maths, especially understanding, definitely shouldn't be rushed. Because as soon as you're being rushed and you get stressed, your ability to understand and get the maths, out the window. You can practice doing things in time conditions, definitely for the exam, but like whilst you're doing the understanding bit, don't feel you have to rush it. Some people, and you may have noticed this too, some people on Facebook started going, "Oi, Ruth, they don't match up. What are you doing here? That's wrong." I was like, "Oh man, yeah." I did make it like that, and I should have maybe just said like, "I'm trying to trick you a little bit. They won't all match up." You had spot on. Not all of them matched up here. Not all of them matched up. I'll show you which ones did match up, and then we'll talk about the other ones. So we've got 1 to 2 matches with lolly to chocolate because there's 1 lolly to 2 bars of chocolate, so they match up. The blue car to red car has to go 4 to 3 because blue car is first, so there's 4 blue cars and 3 red cars, so it's 4 for the blue car, 3 for the red car, so it has to go with this one. We can't muddle it up and make it, we can't just switch that around. We would have to write this the other way around. These two don't match up. Here for yellow mug to green mug, we have 3 yellow mugs, 2 green mugs. So that ratio should have been 3 to 2 there for that one. This one should have been 3 to 2. So yeah, I was being a bit tricksy there. I was being a bit tricksy. But yeah, hopefully that's the point of putting that in was to make sure you know that ratio has got to be the right way around. I can't say, well, a good example is when you're cooking. If we say the ratio of eggs to flour is that there's 2 eggs for every 150 grams of flour. If I switch that around just randomly, I'd end up with 150 eggs to 2 grams of flour. Very different recipe. Don't try it. Don't try it. Okay, let's have a little look at how this links then to some direct proportion. We're back to Carly. Remember Carly? Remember how much she gets paid per hour? She was getting like £11.75 per hour, right? Carly's pretty chuffed about that. She's doing handstands about it. I've started a little graph here for Carly. I've started a little graph showing roughly how much she gets paid. Not exactly. Like representing £11.75 was challenging. So I just decided to put pound coins on to say she's been paid. Like, you know, in England, if you're not from England, this is the money we use. It's a standard coin. Okay, so it's not perfect, but it gives an idea. So this is the graph. Money she's earned, and this is the hours that she's worked. Okay, I'm asking you, as she works more, what's going to happen to the money? So what's going to happen to the money as she works more hours? So we're going along here. As she works more hours, what's going to happen to the money that she earns? What are you expecting that graph to look like? I'm going to give you a chance to have a little think about it. So lots of there was a really good way. Somebody explained it in one way. I can't remember the exact words that somebody used on Facebook, and it was really good, and I really liked it. But it's gone from my brain now. But essentially, you would like she's being paid per hour. So the more hours she works, the more money she's going to earn. So that graph is going to go up. Those pound coins are going to get higher. And as we go further to the right, I'm not very good with my right and left, we're expecting that graph to get higher and higher and higher. So fortunately, I prepped a slide that showed exactly that. So as that, you see, as she works more hours, the money she's earning is getting higher and higher and higher. And we can see this going up. How much would Carly have got for working 0 hours? This is a 2-part question. And where would I put that on my graph? How would I represent this on my graph here? So how much is she going to earn for 0 hours? And whereabouts would you plot that on the graph? So that one stumped people a little bit. That question stumped people a bit on Facebook. People will understand. They were like, well, she won't get any money. She won't get any money. Why are you asking us a question? It doesn't make sense. If she's not working. And it's still sometimes in maths. Especially when you're answering like really, really set up teach questions like that one. The answer is the obvious answer. She gets no money if she's not worked any hours. And lots of people explained where that will be plotted really, really nicely. In the very bottom left-hand corner, right down here. This is called the origin or 0, 0. It's no hours and no money. So it would look like this. This is what we would expect this graph to look like. So it's a direct proportion graph because it starts at 0, 0. When you've got work no hours, you get no money. And it's going up in a straight line. It's increasing because the more it's going up the same amount every single time. The more hours she works, the more money she earns. And it's going up by £11.75 every time. We already worked that out. I want to introduce Hannah. So I've put Carly doing a little handstand on her line now. If I introduce Hannah, remember Hannah here. She worked for 6 hours and got £67.50. She earned £11.25 per hour. What would Hannah's line look like on this graph? What would Hannah's line look like if we popped it onto this graph as well? How would you compare it to Carly's line? What do you think would be the same? What would be different? So I'm going to give you, I don't know how much time to give you to think about it. Lots of people on Facebook were saying, well, it'll be slightly down. They were using lots of cool words, which I understood what they meant. It'll be slightly down, slightly below, slightly less, all those sorts of words than Carly's. Shall I show you? I'll show you. Okay. Can you see this blue line? So it is below, isn't it? It's slightly below. It's, for mathematically speaking, the words we're looking for is it's less steep, or its gradient is less. It's not going up as quickly. However, it still goes through the origin, 0, 0. She still earns no money if she works no hours. So at that point, they're the same, but they go off at slightly different angles to each other because she earns less per hour. Okay, so direct proportion, where was I going from there? Oh yeah, we're going to have a little look at some simplifying ratio now. So I talked about that a little bit, didn't I, already? So when we looked at, I'll get this one. When we looked at Carly and how much she was earning, we could write down a ratio for how much she earned for 5 hours here and then I could work out how much she earned for 1 hour. And what I'd done there is I'd simplified the ratio. I'd divided both of these sides by the same amount, and I'd used those pegs to do that. I'd said to get from 5 hours to 1 hour, I divide by 5. And therefore, I do the same on this side. I divided this amount by 5 to get how much she earned in that single hour. It's a little bit like simplifying fractions. You divide them by the same amount, or you can unsimplify them. I don't know what the word for that is, and multiply by the same amount. So I'm going to show you some donuts. Now, I don't know what you feel about donuts. Donuts, to me, I always think they look really pretty. But then if I ever buy one, I'm so disappointed. I don't actually like eating them. I just like looking at them. And yet I fall for it. Not that frequently, because I've not got a really sweet tooth, but I do fall for it. Every now and then I'll buy one and I'll be like, oh, yeah, they're not great. But yeah, I don't know. They look cool on pictures. So here's my donuts. Well, not real donuts. Here's my pictures of donuts. And we're looking for the ratio of blue donuts to pink donuts. I've got 1, 2, 3, 4, 5, 6 blue donuts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pink donuts. And we've got 1, 2, 3, 4, it's 6 different ratios at the bottom. Some of those ratios represent the ratio of blue donuts to pink donuts. So I'd like you to highlight those or circle those or pick those ones out in some way. Some of them don't. So which ones do you think are actually right ratios, ones that work for this, and which ones are not? Again, I'm going to give you a little bit of thinking time about that. Again, I'm being a bit sneaky here because I'm not telling you how many of them. I'm just saying some of them work, some of them don't. So if you can spot which ones. Okay, so I'm going to show you which ones, and then we'll talk about why. All of the ones I've ringed in green are ratios that describe the relationship between the blue and the pink donuts. So all 4 of those work. 6 to 12, 12 to 24, 3 to 6, 1 to 2, but not the other ones. Okay, let's have a little look at why that is now. Let's have a little. Ooh, that extended quickly. What a surprise. I love some exciting things like that. Okay, so 6 to 12. You might notice that both of these numbers are in the 6 times table. So that means I can divide them both by 6. So I can do 6 divided by 6, which gives me 1. And I can do 12 divided by 6, which gives me 2. And that takes me straight to the ratio 1 to 2. But you might not have noticed the 6 times table. More commonly, what people are most comfortable with noticing is even numbers. 6 and 12 are both even numbers, so we could divide them both by 2. And if we divide 6 by 2, we get 3. And if you divide 12 by 2, you get 6. And then after that, you might notice that both of these are in the 3 times table. And if you divide them both by 3, you end up getting to this 1 to 2. So a couple of different ways to get to the same thing. The one that probably threw people the most on Facebook was the one that was 12 to 24. And that one, essentially, all I've done is double both numbers. So I doubled the 6 and doubled the 12. So ratio is less about the actual amount and more about the relationship. The 1 to 2 is saying that for every 1 blue donut, I get 2 pink donuts. In fact, I drew on my screen the other day, which sometimes gets me into trouble, but I've worked out how to clean it off. So hopefully my husband, he's actually in the house, so I'm whispering. Don't tell him that I'm drawing on the screen. But like if we take the 6 to 12 is more obvious because there's 6 of those and 12 there. If I go to the 3 to 6, if I group this into threes, you can see that I get 2 lots of 3 donuts. So on this side, to have 2 groups like that, I actually have to split it up into 6s. So I have to have groups like that instead. So it's talking about the relationship rather than the actual amount, which is why all of these work. The 12 to 6, you might notice, is the wrong way round. I've written it the wrong way round. I've written pink to blue instead. And similarly with the 6 to 3, it's the wrong way round. I've done it pink to blue instead. So both of those ones were just that they were the wrong relationship, the wrong way round. Okay, whilst I clean my screen, actually, I'll talk to you about this and then I'll clean the screen. So what I'm going to do now is I'm going to give you a ratio and I'm telling you I've simplified it. I want you to say if I have simplified it correctly or not. If I haven't, you can correct it. Okay. I do need to clean the screen because it's all over. These cloths work really well. These lovely microfiber cloths work really well. Okay, so the first one is here. And let's get that clean so you can see. The first one is it. So I started with, oh, wait, give me a sec. Here we go. Yeah, there we go. Oh man, that's not as clean as the other day. I'll have to improve that later. £10 to £8. I'm saying I've simplified it to £5 to £4. Are you happy with that? Have I done that correctly? Have I done that one correctly? Okay, I have done that one correctly. Yeah, that is as simplified as I can go. So when I'm looking at the times tables, the numbers 10 and 8 are both in the 2 times table. So I divide them both by 2. That gives me 5 and 4. And the only times table that 5 and 4 are in together is the 1 times table. But if I divide by 1, I just get the same thing again. So I can stop there. I've simplified that as much as possible. Perfect. Next one. Have I simplified this? So I've got 18 centimetres to 6 centimetres. 18 centimetres to 6 centimetres. And I've simplified that to 9 to 3 centimetres. Have I done that one correctly? Okay. This one, no. The answer is no. It's that sort of... I've been tricksy again. I've been a little bit tricksy because I have simplified it, haven't I? I divided the 18 by 2 to get 9 centimetres. And I divided the 6 by 2 to get 3 centimetres. But I haven't fully simplified. So if I'm being really technical about it in an exam, if they ask you to fully simplify something, you have to keep going until you can't simplify anymore. If they don't ask you to simplify, you don't need to. You're not going to lose marks if you don't do it. But if they ask you to, you have to make it as simplified as possible. So here, 9 and 3 are both in the 3 times table. So we would divide both of those by 3. So that gives us 3 centimetres and 1 centimetre. And that would be my fully simplified answer. Okay, next one. I've got 65, and I'm going to simplify that to 3 to 2.5. 6 to 5, I'm simplifying that to 3 to 2.5. Have I simplified that correctly? Okay, what do we reckon? Confusing one again. Bit of a confusing one. Essentially, no. No, I have not simplified that one. The issue being, you can have a decimal in a ratio. You saw that earlier with money terms, but it's not considered simplified if it's got a ratio in it. A simplified ratio should be whole numbers only. So integers, they're called, but whole numbers is what us normal people would say. So 6 to 5, I would look at the 6 and the 5 and I would say, what times table are 6 and 5 both in? The only times table they're in together is the 1 times table. If I divide by 1, I get the same numbers again. So I can't, that is as simplified as it can be. I can't simplify that one anymore. Okay, I've got one last one for you. I'm not being tricksy anymore. Sort of. There's more than one answer. I've got to be kind. There's more than one answer. Because I didn't say that to Facebook people and they were a bit like, what? Which is fair enough. Okay, here we go. £3 to 50p. Have I simplified it if I get 6 to 1? If I get 6 to 1. What do we reckon? So I essentially got some people saying, yep, you definitely have, and some people saying, nope, you absolutely haven't. And both were right. Both were right because of the units in this one. So I'm going to turn my board that way. I've got £3, and the units are really, really important. £3 to 50p there. I need, if I want to simplify this, I need them in the same units. So what I did there was I put them both into pennies. So 300 pence to 50 pence. And then I spotted that I could divide both of those by 10 to give me 30 pence to 5 pence. And then I spotted both of those are in the 5 times table. So I divided both by 5. That gave me 6 pence to 1 pence. And I didn't need to write the pennies after that. As soon as they're in the same units, I can drop the units with ratio because it's just the relationship. However, some people quite rightly said, 50 pence, that's a decimal, Ruth. That doesn't work. So yeah, you're quite right. Yeah. I can't have it. You can't have, if you turn it into a pound, you can't have £3 sort of to 0.5 pounds, can you? That's not simplified. But funny enough, actually, if we then double both of those to get £6 and £1, I end up back at the same ratio. Isn't that cool? So yeah, we could do it a couple of different ways essentially, and it would have been fine for you to say one of them works and one, like it's hard to see both sometimes because you go down your track, and that's normal. So yeah, that one I did. Right, last thing I want to talk about then is the bar models. I sort of introduced you to them, but we can use them in multiple different ways. So we can use the bar model like we did with that proportion question where we're just talking about a single person. We can also use it to compare different amounts, which is what we're going to do here, okay? So a restaurant employs chefs to waiters in the ratio 2 to 9. If they have 6 chefs, how many waiters do they have? Now, there is a couple of different ways to do this. You can absolutely do it without bar models, but I want to introduce you to this. This is a picture here where I'm representing this information as a bar model. Before we talk you through it, just have a little look and see if you can see any links between the worded question and the picture that I've put on the screen, the orange bars and the sort of pinky ready bars. Okay, so hopefully, I don't know. Well, we'll see. Lots of people struggle to see this on Facebook, which is, so I do want to talk you through it. This 2 to 9 here is this ratio, and it's linked to chefs to waiters. So chefs comes first, so the 2 relates to the chefs. Waiters comes second, the 9 refers to the waiters. So this bar model here, I've got 2 bars for the chefs and 9 for the waiters. And I can use that to answer this question. So I can then, well, I'm going to draw, what I'm going to do is I'm going to show you how I would do that from scratch on a little whiteboard here. So if I have, here's my whiteboard, I know that it's chefs to waiters. So I'm going to put C to W to remind myself. And then the ratio is 2 to 9. I'm going to pop that underneath. So I'm linking the 2 to the chefs, the 9 to the waiters. And then I'm going to draw 2 bars, keeping them roughly the same size, and labeling that with a C for the chefs and a little W for the waiters. And I'm going to do 9 bars for that one. So that's 2, 4, 6. Hopefully I can fit them all on. 8, 9. There we go. Just squeeze them on. Just. So if they have 6 chefs, I know that this section here is worth 6. And then I can start working out, well, if both of those boxes together are worth 6, each one of them must have like 3 little chefs inside. No, we're not really putting chefs in boxes, but 3 people representing 3 little chefs. And then, now I've gone down the route of that Kentucky Fried Chicken song. Get it out of your head, Ruth. That means all of these boxes must also have 3 people in, but these are representing 3 waiters. My 3s are really messy here, but hopefully you get the idea. Each of them is worth 3. So now I can work out how many waiters there are by saying, right, there's 9 boxes and there's 3 waiters in each box. So I do 9 times 3, which gives me 27 waiters. And that's how we use the bar model to do that. If you don't like the bar model, that is absolutely fine. You do not have to use it. Traditionally, when I was taught how to do ratio, I would have been taught how to do it through just a written method where we say chefs to waiters, and we put the 2 to 9 underneath. And we know that we've got 6 chefs. We don't know how many waiters there are. So we'd look at the relationship. We'd say, right, we're multiplying that 2 by 3. So we're going to do 9 times 3 here to get 27 waiters. So this number would be 27 because of the 9 times 3. I've got a similar question here. You're welcome to use, neither one is like better or worse. There's going to be situations where you find one easier than the other, or you might just really, really hone into one and find the other one not useful at all. Do what suits you. That's absolutely fine. I'm going to give you another question similar to that to have a little think about now. You're welcome to use a calculator for this. Don't worry too much about that. We're just going to focus on the ratio bit. Okay. So we've got Claude is going to wash his car. He will use 490 mils of water. How much soap will he need? And this is his soap. It says mix with water in the ratio 2 to 7. And that should say soap to water. Somebody pointed that out to me and I totally forgot to add it on. I will put it on now. So it should say soap to water. Okay. So give you a little bit of time to have a little think about that question. Wants to break free. You will stay there, post-it note. People need to know this information. It's important. So Claude is going to wash his car. He will use 490 mils of water. How much soap will he need? Mix with water in the ratio 2:7 soap to water. I'm going to have to stop holding that now so I can clean a whiteboard off. Okay, so hopefully that's given you enough time to have a think about it, at least, if not have a go at that question. Let's have a little look. So I've got my ratio here, soap to water, 2:7. I'm going to start off with the bar model. So I'm going to do 2 bars for the soap, and I'm going to put a little S there to remind me that's the soap, little W for the water, and I'm going to do 7 bars for the water. So 1, 2, 3, 4, 5, 6, 7. You can see I've not quite managed them in the right size, but roughly. In this case, he's going to use 490 mils of water. So it's the water bit that I know. So 490 mils of water is going to fit in those 7 boxes. So to find out what goes in each individual box, I need to divide this by 7. So 490 divided by 7. You could have done that on a calculator, or if I use a little bus stop, 7 doesn't go into 4, but it does go into 49 7 times, and 7 doesn't go into 0. So we get 70 mils in each box. 70 mils in each of these boxes. When I add those up, it's going to give me 490. But most importantly, I also need 70 mils in my little soap boxes. So 70 and 70. So I can work out my total number of soap by adding those two together and getting 140 mils like that. And as I said, you wouldn't need to show any more working than that. That would be absolutely valid to use that in an exam situation. If you prefer using the ratios, you can put 2:7 for your soap to water. Oh, I've put a 4 instead of a W. We knew how much water that Claude was going to use, so we'll put the 490 underneath the 7, and we've got to work out what we're multiplying here. Some of you may have spotted it because you might know the link between 7 and 49. Otherwise, you would have had to do 490 to work out what you do divided by 7 to see how you go backwards. And then whatever you divide by, you're going to multiply in that direction to get there. So 7 times 70 is what gives us 490. So I would have to do 2 times 70 to work out how much soap, which gives me 140 mils there. Okay, that is where I'm going to leave this lesson. Before I say anything else, really important announcement is that next week I am not doing any lives. I'm not going to miss any lessons. I was going to have 2 weeks off in October. I'm just going to have 1 week off now, and I'm just going to shift everything back. I'm at a family funeral. We live miles away from all of my family, so we've got a lot of traveling and I just can't fit it all in. So I've made the decision that next week we'll have a week off of live sessions. So that was important. That's the first thing. The second thing is that if you want me to say hi, head over to the Facebook page if you've got Facebook. Don't worry if you haven't. If you haven't, hi to you guys. But if you do want me to say hi, head there now and just say a little hi on the post there, and I will say hi back to you. Whilst I'm giving you a chance to do that, I'll do my little spiel. I am really confident now that I'm going to have my water activities pack out and ready in October. I'm getting really close. I've got the stickers, I've got the freebies. I'm just pulling the last things together and then I'll have to get this printed. I'm very excited. But for now, if you are not paying me and you would like to, you can sign up for £5 or £6 a month. And that supports my lessons. That's paying for all the work I do towards these lessons and the lives. But you get a little thank you through the post, which currently is my Math Mob memo all about fractals. So it's hands-on ways to explore fractals in there. And it comes with some beautiful origami paper and some stickers that I designed. And then, yeah, in October, it'll be my weather one coming out. Well, she says, I've said that now, so I really feel the pressure to do it, but I'm really confident it's going to be ready. Really confident. Okay, right, let me say some highs. Found Facebook. I feel like I'm an old lady there. Just pulling back from it to look at it. Oh, no, don't start doing that, Ruth. Don't start doing that. Okay. I think Claude's car is going to need a bit more than soap and water, Jacob, Claude's car is perfectly modelled on my own car, which gets washed about once every 18 months at best. And you wouldn't be wrong. I think from experience, it definitely needs more than one bucket of soap and water for sure. Probably, a little bit more. Yeah, not cool. Hi, Jacob. Hi, nice to have you here. And who else have we got? Oh, Harmony. Hi, Harmony. Nice to have you here too. Good morning, guys. You were up bright and early for this. Right, I'm just going to refresh just in case there's any more highs because that's important. I like the connection of these. Have we got any more? What's it doing now? Oh, okay. Oh my gosh! Tegan, you're joining for the first time. Woohoo! Oh, I should have said that so I'm going to have this week off lives. I'm going to be working in the background, but I have this week off the live sessions. We're going to start a new module actually, which is quite exciting. So Tegan, yay, you can come and join us on that. Woohoo! Awesome to have you here. Right, I think I've got everyone, so I'm good now. I think I've got everyone. Oh gosh, my thing just did it right. Why does it do that to me? It just shuffles every time I go on and it sends your eyes all funny. No, I've got everyone. That's perfect. Thank you for joining me live, guys. It's really, really lovely that you're here. And if you are watching on the catch-up, that is also awesome. Thank you so much for joining. You can catch Maths and Dinosaurs in about an hour and a half if you want to join me for that as well. I'm doing scales and spines today. But otherwise, have an amazing weekend. And I will see you all in 2 weeks' time. Bye.